All right, let's talk about the exterior angle theorem, and we'll get right into it with some vocab. First, the word polygon. That's a word I'm sure you've heard before, but that's just when we say polygon, we're referring to any flat two-dimensional shape that has straight sides. So that would include triangles, every type of quadrilateral, pentagons, hexagons, octagons, dodecagons, any of your gons. The one thing that would make it not a polygon is if it was rounded somewhere. So if there was an arc or a circle, oval, something like that, no longer a polygon. But if it's got straight sides and it's flat, it's polygon. Interior angles. Every polygon has interior angles. Those are just the regular angles on the inside of a polygon. So if you look at this diagram here with the triangle, it has three interior angles. And I'm just going to write those down really quick because that'll be helpful when we talk about exterior angles. So interior angles. We have one at angle A at the top. So interior angle. So angle A. We've got one down in the bottom left at angle B. That's an interior angle. And then at point C, we've got a couple angles here. So the interior one is going to be this one right here. And the way we're going to write that is angle ACB. So those are our three interior angles, the three angles on the inside of the triangle. And normally we wouldn't even have to use the word interior. We would just call those the angles of the triangle. But now we're introducing this other concept, so we have to be clear. We're talking about exterior angles now. So exterior angles, like the name suggests, are angles on the outside of a shape. And the way you get these is by extending one of the sides. So on our triangle, if you take side BC here on the bottom, and you just extend it out in one direction, then you create this angle on the outside. And that's called an exterior angle. Now you could create exterior angles at any corner, any vertex of the triangle. So we only have one in this diagram, but you could create more. So the one we have here, it says D degrees, but if we want to name this, it would be angle ACD. So that's the exterior angle. And the other little bit of vocabulary here that's going to be important is the words opposite and remote. And so one thing we've talked about with angles is adjacent angles. Adjacent angles are angles that share a side, that are next to each other. So on this diagram, the two angles here at point C are adjacent. They bump up against each other. They share a side. Opposite or remote means the angles, they're related because they're still on the same polygon here, but they are not adjacent. They are across from each other. So let me get a different color so this stands out. So the angle that's adjacent to our exterior angle, like we said, is ACB. That's adjacent. It's next to. The other two angles, did I spell adjacent correctly? Yeah, we're good. The other two angles are opposite angles because they do not touch this angle. So they are opposite. So angle A and angle B are the opposite angles. So that's only important for this very next thing we're going to talk about, which is the actual exterior angle theorem, which says the measure of an exterior angle of a triangle is equal to the sum of the measures of the two opposite interior angles. The other word you might see instead of opposite is remote. So here's the idea. If we know that angle A up here at the top, let's say this is a 55-degree angle. If it lets me write that, 55 degrees. And let's say angle B down here is, let's say this is 62 degrees. Then if I want to find my exterior angle, what I would do is I would add together these two interior angles that are across from it, that are opposite it. So I would take 62 and 55. I would add those together, and I would find that this angle right here is 117 degrees. Now, you don't even have to do that because we can use other stuff to find out that angle. So here's something I want to show you really quick. On a triangle, we know the angles have to add up to 180. So let's forget about the exterior angle for now, and let's just figure out what this third angle on the inside of the triangle is. So let me erase some of this extra stuff here. So we added up the two angles we knew already, the 55 and the 62. We got 117. If I want to find my third angle, I'm just going to take 117 and subtract it from 180 because I know those have to add up to 180. So when I do that, I get 63 degrees. So this is 63 degrees. So if I then wanted to find the exterior angle, what I could do is say, well, these two angles here, they make a straight line. They have to add up to 180. So I would take 180 and subtract my 63, and I would get, again, 117. So there's different ways to arrive at the same answer, but the quick way to do it, if you know two of the two opposite interior angles, if you want to find the exterior angle, just add them together. All right, let's do some examples and see what your problems will look like when you're dealing with this theorem. Here we've got just some solve for x and solve for y, just using angles that are filled in. We're going to find missing angles. So again, the quick way to solve for x, if it's an exterior angle, is to add together these two interior angles that are not adjacent to it, that are opposite. So we're going to take 64 and 45. We will add those together, and we will get 109 degrees. So x is 109 degrees. Over here, we have two missing things. We got to find x and y. So there's, again, different ways I could do this. I could add together these two angles and then subtract 180 and find y. And then I have a couple different ways I could find x. Here's how I want to do this, though. And again, different ways we could go about this. But I'm going to take these two angles here. I know those have to add up to 180 because they make a straight line. And that's going to be true whenever you have an exterior angle that's adjacent to an interior angle. Whenever they're next to each other, they will always add up to 180. So I'm going to take 180. I'm going to subtract 58, and I get 122 degrees. So my exterior angle here is 122 degrees. Now I got to find y. Different ways to do that, but I'm going to use the exterior angle theorem, and I'm going to say my two opposite interior angles, the 60 and the y, have to add up to give me the exterior angle, which is 122. And then all I got to do here to get y is subtract 60, and I find that y is 62 degrees. So one thing you'll notice here is everything we're doing is based on two rules. It's based on the idea that the angles of a triangle add up to 180 degrees. And it's also based on the idea that when you have two angles that are adjacent, that are next to each other, that form a straight line, they add up to 180 degrees. Everything we're doing is based on those two things. Let's continue here. All right. We've got a little bit more complicated problem here, but it uses the same principles. It says solve for y. You'll notice we have an exterior angle, 116 degrees. We have the two opposite interior angles. So what we know is that angle D and angle C have to add together to give us 116. So I'm just going to take what they've given us, which is 4y and 7y plus 6. I'm going to add those together, and it will be equal to 116. And now I just solve my equation for y. So I'll combine my like terms. I get 11y plus 6 equals 116. I subtract the 6. And this is going to work out really nicely. I get 11y equals 110. When I divide, I find that y equals 10. So if you want to check your answers, plug in 10 for y. See what these angles end up being. You'll find that this up here is 76 degrees. Down here, this is 40 degrees. And to completely check it, figure out what this third angle is by adding those together, subtracting from 180. And what you should end up with is 64 degrees. And so it should all work out, but don't hesitate to check your work. So y is equal to 10. We got that by saying these two angles have to add up to give us this angle on the outside. All right, last one of these. It says find the measure of angle NED. So really quick, I think we've seen this before. I just want to be really clear what this means. This means measure of. So whenever you see that little m, it means you're finding amount of degrees, like how many degrees is this angle. So NED, angle NED, is this angle right here, NED. So the measure of this angle is 9x minus 8. So what we know is that is an exterior angle. It's on the outside, which means it is equal to these two interior angles added together. So we will take 5x minus 10. We will add 50. And when we do that, it has to be equal to 9x minus 8. So slightly more complex equation, but nothing we can't handle here. So let's simplify this a little bit. I'm going to combine my like terms. I'm going to get 5x plus 40 equals 9x minus 8. I always like to take the smaller of my two numbers and move it to the other side when I'm putting my x's together. So I'm going to subtract my 5x just because when I do that, I know I'm going to get a positive number on the other side. But you can do it different ways. I get 4x minus 8. I'm going to add my 8 now. And I'll divide, and I find that x equals 12. Great, I know what x is. However, this problem's not asking me to find x. It's asking me to find the measure of that angle. So I have one more step. And this is the most common mistake I've had in every geometry class I've taught is just missing this instruction right here. So the hard work is figuring out what x is. But once you know what x is, you got one more thing to do. You got to plug it back in and figure out what this angle is. So my final step is to take my value of x, plug it in. So 9x minus 8 becomes 9 times 12 minus 8. And then I will work that out. 9 times 12 is 108. 108 minus 8 is 100. So measure of angle NED is 100 degrees. That is my final answer. And again, don't hesitate to plug stuff in to check your answers and make sure that it all works. That is correct, 100 degrees. So that's the exterior angle theorem. Two angles on the inside add together to give you the one on the outside. Make sure that the two angles on the inside you are using do not touch the angle on the outside. So there you go. So good luck with exterior angle theorem.